In this video, we'll be looking at properties of logarithms. First, we have four basic properties: log base a of a equals 1, log base a of 1 equals 0, log base a of a to the r equals r, and a raised to the log base a of r equals r. These are all very similar to the main property that we looked at in the previous section. Let's utilize those. In this first example, we'll be looking at log base a quarter equals 1. Remember, you're asking yourself 1/4 to what power equals 1? Right? How can we raise 1/4 to a power and get 1? Well, that means we would have to be 0. That's using this property here. Then in the next one, we have 5 raised to the log base 5 of 2. Notice you have a base raised to the log of the same base. That's using this property here. That's just going to be the input of the logarithm, in this case 2. And then we have log base 3 of 3 squared. Again, you're asking yourself 3 to what power gives us 3 squared? Well, that has to be 2. The main properties that we're going to be focusing on today are these. You have a product, log base a of m times n. Well, we can expand that single logarithm into a sum of 2 logs. Notice the base stays the same and we just add the m and the n. And very similar to the product, we have a quotient rule. Log base a of m divided by n, we can expand that single logarithm into a difference of logs. We have log of m minus log of n. Let's practice those. For example, we have log base 4 of 16 divided by y. Since it's division, we can expand this logarithm into a difference of 2 logs. Log base 4 of 16 minus log base 4 of y. The numerator is the first log, the argument on the first log, and then we subtract the denominators. Next, we have log of 100 times x. We can expand that single log and make it a quotient. Log of 100 plus log of x. That product becomes a sum of 2 logs. One other property that we'll be looking at is the power. Notice here we have log base a of m raised to a p. If we want to remove that exponent off of the argument, we can just drop it down into the front of the log and it becomes a factor. P times the log. So let's combine the product, quotient, and power rule all at once and expand these logarithms. So log base 5 of x squared times y. Let's first take care of the product. Notice we have x squared times y. That means we can expand this logarithm into 2 logs by adding them together. The base stays the same. Make sure you copy down the base. And that first step is to just expand the quotient, the product. The product becomes a sum. And now we have this power on our x. We can drop that down to the front of the log. And we have 2 log base 5 of x plus log base 5 of y. And now we have fully expanded this logarithm. In the next example, we have the natural log of e squared divided by 7. First, let's take care of the quotient. when we expand a quotient, we're going to use subtraction. So we have natural log of e to the 7 minus natural log of 7. And now we can take care of the exponent. We can just drop that 7 down and make it a factor. 7 times the natural log of e minus the natural log of 7. In this one, we have multiple things going on. We've got a product, we've got a quotient, and we've got an exponent. So we'll combine all of the steps here. The first thing I'll do is take care of the quotient. Log of 100x minus log of y cubed. So 100x divided by y cubed, that quotient becomes subtraction when we break it apart and expand it. Now notice in this first piece, it's a product. So we can expand this into two logs using a sum. Log of 100 plus log of x minus, here we'll use the power rule, 3 log y. In the next one, again, we have multiple things happening. Let's take care of the quotient first. This is log base 2 of p squared r minus log base 2 of 8 square root of z. In this first section, we have a product and a power. Let's take care of that at the same time. So we have log base 2 of p, and the square I'm going to pull out to the front, pull out that exponent, plus log base 2 r. And then we're going to subtract. Here again we have a product, so let's make a sum of those. We have log base 2 of 8 plus log base 2 of the square root of z. And we do want to put that in parentheses because we're subtracting this single log. So when we break this single log into a sum of two logs, we need to make sure we have that negative on the outside so that we remember to distribute the negative. Now we just need to simplify a tiny bit. Copy the first part, 2 log base 2 of p plus log base 2 of r minus log base 2 of 8, and there's an exponent on this square root. You know, it's not explicitly stated, but remember the square root is really z to the 1/2 power, so we can actually bring down that 1/2 out to the front, and we'll also distribute the negative sign. So we have negative 1/2 log z. Again, the square root is z to the 1/2 power. We're bringing the 1/2 down to the front. And now it has been fully expanded. In this one, we have 3 things that are being multiplied on the inside. We have 10 times x cubed times the square root of x plus 1. So this is just one big sum. Log of 10 plus log of x cubed plus log of the square root of x plus 1. And now we can take care of some of those exponents. Log of 10 plus 3 log x plus 1/2 log of x plus 1. In this example, we're going to condense this long expression into a single logarithm. Right away, notice that you have a double negative on the end. If you ever see a double negative on the end like this, it's probably best to factor out a negative to begin with, and it's just going to make our life a little bit easier if you recognize that at the beginning. If you don't recognize it, it's okay. It's just helpful to catch it at the beginning. So I'm going to copy the first part. And on the last two, I'm going to factor out a negative sign. So I'm going to pull that negative out to the front. So all I'm doing is I'm pulling these two negatives out, factoring out that -1. Now let's go through and take care of exponents. If you see any exponents, let's take those up where they belong. For example, log base 4 of x squared plus log base 4 square root of y minus, these don't have exponents, the first one doesn't. Then we have log base 4 of p cubed. Now we have a product here, or a sum that will become a product. Same thing inside the parentheses, we have a sum that will become a product when we condense. So we have log base 4 of x squared square root of y minus log base 4 of zp cubed. Finally, we have difference subtraction here. When we condense these two, it will be a quotient. So we have log base 4 of x squared square root of y divided by zp cubed. And notice we have condensed this down into a single logarithm. Our goal here is to get 1 log. In the next example, it looks like we have a sum, a difference, we also have a power. Let's go through and take care of the power first. Natural log of x plus 1 plus natural log of x minus natural log of y to the 1/2, which is the square root of y. Now we have a product, right? This sum will, when we condense, will become a product. Natural log of x times x plus 1 minus natural log square root of y. Then subtraction, this difference when we condense will become a quotient. So we have the natural log of, I'm going to go ahead and distribute in the top and get x squared plus x. Then in the denominator we have square root of y. And we now have a single logarithm. Next we have the change of base formula. Log base b of m equals log base a, notice that's a new base, of m, which is here, divided by log base a, the new base, of the original base. This formula will be helpful when we're solving equations later. So we want to use the change of base formula on the calculator to evaluate this expression. Now, if you have a fancier calculator, you can do this automatically in the calculator. The calculator understands different bases like base 3. But if you have an older 83 or maybe even an older 84 calculator, the different bases are not necessarily going to be easily done in your calculator. We'll need to use the change of base formula. All calculators will have the common log and then the natural log. So we can use these two along with this formula to find the value of this expression. For example, let's use the change of base formula. Log base 3 of 5, we can rewrite that as log of 5 over log of 3. just using the common log, right? The base 10 log. So log of 5 divided by log of 3. That will give us roughly 1.46. But we don't have to use the common log. We could also use the natural log. Right? We could do the natural log of 5 divided by the natural log of 3. And we should get the same thing. Right? We get the same thing. So the base that we use here, it doesn't matter. As long as it's the same base that we use on the top and the bottom, doesn't matter what we use. Most calculators will have the common log and then the natural log. Not every calculator will be able to input this exactly into the calculator. Now, if you do have one of the fancier calculators, I'll show you how to do it. We go to Math, and then we scroll near the bottom. There's a log base button or function. Hit enter, and now we can input which base we want, like base 3 and the argument 5, and we can see that it gives us the same value as the change of base formula. Even though most of you will probably have this function where we can input it directly into the calculator, you still need to know the change of base formula for things we'll do later. So don't completely ignore this. Even if your calculator has the shortcut, we still need to know how to do it.